Salam sejahtera. Today we will continue our discussion in the Rankine cycle. So first thing first, we have to know the process that involved in the Rankine cycle. So we have four processes. Process 1 to 2 is isentropic compression in a pump. 2 to 3 is constant pressure heat addition in a boiler. 3 to 4 is isentropic expansion in a turbine, and 4 to 1 is constant pressure heat rejection in a condenser. This is the TS diagram of the Rankine cycle, and if we can see here at state 1, the liquid that enter the pump is in saturated liquid. Okay, and the liquid that enter the inlet of turbine is in superheated. And Rankine cycle, we have to remember that it is the modification of the Carnot cycle. Next, we go to the analysis of Rankine cycle. So all of these components are steady flow devices. We already covered SFEE devices in our previous chapter. So each of these components we can analyze using SFEE equation, which given in this equation. Okay, since kinetic energy and potential energy can be negligible, then the SFEE we can reduce to this equation: Q in minus Q out plus W in minus W out is equal to enthalpy at the exit minus enthalpy at the inlet. So you have to remember this. Next, we go to the analysis of the SFEE for each of these components. Okay, we start with the pump. Okay, pump, we can also say that it is a compressor. Okay, and we know from our previous lecture that the pump has W dot in, work input. And since the pump is adiabatic, therefore we can say that there is no heat in and heat out. So from this SFEE equation, we can cancel out Q component and W out. And then the formula will be given as W in is equal to H2 minus H1, H exit minus H inlet. And we also have another formula for W in for pump is specific volume multiplied with the differences between P2 minus P1. Okay, and please remember from TS diagram, we can see that state 1 is in saturated liquid. So if you want to find enthalpy or specific volume or entropy, you have to find at the subscript of F, that is fluid, since this is saturated liquid. Okay, at the respective pressure. Okay, so these two equations you have to remember. W in is equal to H2 minus H1, and W in is also equal to specific volume multiplied with delta P. Next, we go to the boiler. The function of the boiler is to heat up the liquid or gas. Therefore, there will be Q in here, and boiler has no work. Okay, so for SFEE component, we can cancel out the W component as well as Q out. So the equation will be Q in is equal to H3 minus H2. H3 minus H2. Next, we go to the turbine. In the turbine, from our previous lecture, we know that it will produce W dot out, work power output. Okay, and the turbine is isentropic. So from SFEE equation, we can cancel out the component of Q as well as W in. Then we have minus W out is equal to H4 minus H3. Okay, if I change the minus to the right, and I will get Q out is equal, H3 minus H4. Okay, next we go to condenser. Condenser has no work. Okay, then from this equation, we can cancel out this component and Q in component, then we will get minus Q out is equal to HE minus H1, then we will get Q out is equal to H4 minus H1. Okay, so all these equation you have to remember. Okay, based on TS diagram and schematic diagram.